You need to distinguish between production, which can be from fossil fuels, nuclear, or from renewable energy, and distribution, the companies that own the transmission line and the distribution lines and the equipment. And when it comes to distribution, regardless of the source of electricity, you have a further distinction between the traditional power grid and the growing field of distributed energy resources, or called as DER. Power generation and the existing power grid have long used industrial control systems based on SCADA. In the US alone, we are talking about 8,000 generating units, 200,000 miles of high voltage lines, and millions miles of local distribution lines, and 180 million power poles.
So even within this enormous existing infrastructure, reliability can be improved by the real-time detection of incidents such as transformer failures, lightning strikes, vegetation encroachment, etc. And IoT sensors can play a role in this and will play a role in this.
DERs can directly send excess power to the main grid. That's the most common scenario today. Or they can feed to a microgrid, which may cover a residential development, a factory site, or a campus. Microgrids are certain to proliferate in the coming years. They require a high degree of automation to control the inverters, the storage system, and its interaction with each building and with the main grid. This means IoT sensors and actuators at every point, but also predictive supply and demand models enabled by all that data. DER will change the structure of the industry, introducing many smaller suppliers, including consumers who will become producers or prosumers as they are called, when they generate more power, especially solar power, than they consume at a given time. The distribution companies become managers of that more complex grid. Monitoring of all those sources in real time requires extensive application of IoT. Also, many consumers are interested in the information that comes from monitoring the grid. If they generate electricity themselves, they want to know how much they produce and whether their solar panels and storage systems are performing optimally. But they also want to know if, when they consume the energy from the grid, does it come from fossil fuels or renewable sources? The network needs to be instrumented to provide that data.
Most people don't realize that today, solar and wind power, including cogeneration by residential solar panels, is limited to about 30%, more or less, of the total megawatts that a utility can handle, because those sources can fluctuate very rapidly with clouds and the wind changing, and the grid needs a substantial, stable baseline from traditional power plants in order to operate correctly. And here, the role of IoT is going to be to predict and alert the utility to a change in the supply from green energy, allowing the utility to react and to bring other sources of energy online in order to compensate for those fluctuations. If clouds block the sun from a solar panel, you can predict that other panels in the downwind direction will soon see the same decrease. And that helps the utility manage the supply side of the power equation. But this implies that you must transmit the value of the power output from the panels and data about wind direction and wind speed at frequent intervals. The same thing applies to predicting the fluctuations in the output of a wind turbine farm. This means sensors and connections, hence this means IoT.